In this video series, we'll discuss how to use Ansys Fluent for the simulation of a supersonic rocket. We'll walk through all the steps from prepping a raw geometry file through meshing, simulation setup, solving, and post-processing the results. In this first video, we'll show you how to use Ansys Discovery to pre-process geometry before meshing, importing a raw CAD file of your rocket parts, and cleaning the geometry. To start the program, find it in your Applications menu. We'll be using Ansys Discovery to prep the geometry. If multiple versions are installed, make sure you select the most recent version, as Ansys files are not backwards compatible. For this simulation, we'll be using Ansys 25R1. When the program loads, the Welcome menu will show recently opened files. To open a new file, navigate to the browser for your file directory and select the CAD file to open. Discovery can import many file types with Parasolid and native CAD formats preferred, followed by step files. When the geometry opens, you can manipulate it by using the scroll wheel to zoom in and out, holding down on the scroll wheel to rotate the geometry, and using Control and Scroll to pan. The first step is to set the nose at the origin. This will help with the use of symmetry later on in the simulation. Use Control and the scroll wheel to select the point of the nose. The coordinates of the nose can be seen in the bottom right-hand corner. To move the nose to the origin, we'll select the entire rocket, go to the Design tab, and select the Move tool. Now, we'll move the point of reference to the nose and set the X, Z, and Y coordinates to 0. Opening up the object tree, we can see that the rocket geometry is made up of many different parts, some overlapping and some inside of each other. Then, with the clipping plane, we can inspect the internals of the rocket. For demonstration purposes, we'll open up another Discovery window to look at the final clean geometry that is the end goal of this work. It can be seen that the final geometry is one solid body with a void space in the tail representative of a nozzle. Now going back to the original multi-part geometry, we'll look at how to clean it up. First, hiding and then identifying individual parts allows us to see what we can combine and what we can modify. To make the hollow main body a solid, we'll use the Pull tool and move the interface all the way to the center, creating a solid. Then, with the Combine tool, we can make the body, the nose cone, and the tip all one component, and then delete empty and deprecated parts and objects from the object tree to keep your workspace clean. As more parts are made visible, we can delete unnecessary parts directly from the object tree. The process of making shell bodies into a solid with the Pull tool, combining multiple bodies into one with the Combine tool, and deleting unnecessary components is repeated for the rest of the rocket. Throughout this process, hiding ancillary objects, changing the coloring of specific objects, and keeping a clean object tree helps keep the workflow organized. And once there's one combined solid object for the rocket body, it can be renamed accordingly in the object tree. And finally, since there's no void space for the nozzle shape, we'll go to the provided complete geometry, copy the nozzle surfaces, and paste them into our working rocket body. The surface representing the nozzle shape might need to be repositioned using the Move tool depending on the model orientation. This surface can then be used to split the solid body and create a void space for the nozzle fluid. Finally, use the Repair tab and click through the Repair tools to check for any gaps, missing faces, edges, and misalignments within the model. A final global geometry check means we're now ready for fluid volume creation and name selections. This will be shown in the next video, where we prep the clean geometry for meshing.